So this is to introduce you to GeoGebra and the activity I'm going to have you do on it. So if you've used GeoGebra before, this is going to be familiar. If you haven't, it'll be pretty straightforward to learn how to use, and you can play around with it a little bit. So you're just going to visit geogebra.org, and you'll see there's a variety of different applications available to you. We want to use the geometry one. So we're going to use the geometry app, and you'll see it open up something like this. Now this gives you a variety of tools. This gives you the basic tools. If you hit more, there's a whole bunch more stuff. I'll do a segment here. Um, Here's the interesting thing. If I make a construction, so if I say do a perpendicular bisector for this thing, click on perpendicular bisector, it'll tell you down here what to do, and I'll just click that right there. And then if I move, because I constructed that to be a perpendicular bisector, the new line will always be a perpendicular bisector of AB no matter how I move it around. Okay, so this is the nice thing about GeoGebra is that you can do these constructions and it maintains whatever properties you define so that you can explore them in multiple cases. Okay, so in this case, I really just want to trash all this because I'm not interested in it so much. I just want to make some polygon. Make it an interesting, non-symmetric shape so that we can kind of explore what it looks like under some translations. I'm going to, I don't necessarily need to see the label on all these. If you just click on them, you get a few options here. I don't want to see the label for those points. I'm going to keep, 3 of the labels so we can see, but it gets a little cluttered if I have them all. Okay. So there's a few things I can do. Let's define a vector because I want to do a translation. So if you see down here under lines, there's vector. Select a starting point and then an end point. So I'm going to do a vector right here. And then if we go down to transform, I can translate by a vector. So select an object and then the vector. So I'm going to select this object and I'm going to select the vector, and you can see we get a transformation there. What's nice about this is that if you change the vector, the image changes accordingly. Right? Look at that, so nice. I'm gonna click on this and just change the color. I'm gonna make it a lighter blue and change the line to like a dashed line so that I can tell that this is an image. Okay. So again, now I've done a translation. And then let's say I do like let's do a rotation. So I'm going to define a point here like so, and I want to transform. I'm going to rotate about a point. So select an object to rotate and the center point. I'm going to select this object and the center point, and the angle I'll choose to be, let's make it say 82 degrees. Let's make it, yeah, that'll work. Okay. And again, you can see that if I move my point, this moves correspondingly. Okay. Now, this object right here is now the product of 2 transformations. The translation by a vector and the rotation around the point I. So this is a product of 2 transformations. My question is, can I get from my original to this one with only 1 transformation? It doesn't appear that I can do it with a translation, because we kind of have some movement here. It doesn't look like a reflection, but maybe there's a rotation I can do. So in order to do that, I'm going to just kind of see if maybe I can figure that out. So I'm going to select it. It looks like maybe I need to put a point around here-ish in order to indicate that this is my other one. I'm going to color this red. Okay. And I don't need to see the name of it. Actually, don't need to see the name of this one either. Just cleaning stuff up. Okay, so I'm going to rotate around this angle right here. So in order to adjust the angle, I'm going to use a little trick here. So I'm going to make 2 line segments like so, and I'm going to measure the angle. I'm going to click like so, and you can see that this right here is 71.7 degrees. Now, in order to, so you'll notice that when I did that, if I go over to the calculator, this is all the stuff I've defined on here. The angle measure is labeled as alpha. Okay, so this angle measure over here is alpha. The reason I'm going to do that is because I want to do a rotation of this object around this point. And what I'm going to do is, instead of doing 45 degrees, I'm going to do alpha. Okay, so I'm going to use alpha as my angle. I'll say OK, and here's I get that right here now. Let me change this to red so that it's clear what I'm doing. Okay, now my object, remember, is to get this red one to match up with this product image right here. And I've gotten pretty close, actually, just kind of randomly guessing, which is pretty nice. The reason it's nice to do it that way is because, notice, as I change this angle, it changes the angle of the rotation. I don't have to enter a new rotation guessing over and over. I can just change my angle. Okay, so it looks like this angle right here, it was 82 before. Maybe 82 again is going to do it. And then if I move this point correctly, I can find a single rotation that does not, or that describes the product of the translation and the rotation. Okay, so this product is closed, like it is in the set of translations, rotations, reflections. I can also do, say, a reflection. So let's define a line here. In order to emphasize what it is, I'm going to do it in green, and I'm going to make it dashed like so. And so then to reflect over a line, I just go down here to transform, reflect this about a line, and we get this over here. There it is. Okay. So now I want to get from the original to this in a single transformation. Here it's going to be more difficult to find a single transformation. Notice again here, if I move this line, the image moves accordingly. Okay. So if I want to get from here to here in a single transformation, a single motion, it's going to take more than just a translation. I can see that. Rotation, maybe, except if I rotate, this is going to have the same orientation. Notice if I go around this counterclockwise, I have A, B, C, D, E, F. Here, if you go around this counterclockwise, you have A, F, E. It's D, C, B. So it's actually reversed orientation. So I'm probably going to need a reflection of some sort. Okay. The problem is that I'm not going to be able to get there in a single reflection. I'm probably going to need a glide reflection. Let's define a line in order to try to do this. This is starting to get pretty cluttered, but this will be the last thing I do. Let's make this orange. And I want to reflect this about this line right here. Let's make this orange as well. And then again, my object is to match up with this object, which I've not done very well with right now. But if I change my line around, I can get it closer. So notice if I move this line enough, I can define a vector that is parallel to this. That would be, so what I can do is let's get a point out here, kind of out of the way. I'm going to define a parallel line to my reflection line through that point, and then I'm going to define a vector on that line. Let's make the vector orange, and here's a nice trick. I needed that parallel line so that my vector always stays parallel to my line of reflection, but I don't actually care to see the line anymore, so I can use show hide and click on it, and then I don't have to see that line anymore. But notice if I move my line around, my translation vector is always parallel to my line. Okay. So what I'm going to do then is let's translate by a vector, translate this by this vector, and this is going to be my final result of the glide reflection. Okay, and I'm trying to get it to match up with this right here. So let's just mess around with this a little bit until we can get it perfect. We're getting closer. Need my line of reflection to move down just a little bit. Maybe a little less than that. And that's getting pretty close. So maybe that glide reflection is it, or one very close to it. So the moral of the story here is I did a product of three motions: a translation, then a rotation, and then a reflection, and I was able to describe that with a single glide reflection. Okay, when I did just a translation and a rotation, I was able to describe that with just a single rotation. Okay, but once I added the reflection, I ended up needing a glide reflection. Okay, so what I'm going to ask you to do is go on Geogebra and create an object, put it through a series of motions that includes at least one translation, one rotation, and one reflection, and then try to find the single motion that maps from your original to your final. In my case, it was a glide reflection. Could be a rotation, could be a reflection, could be a translation, depending on how you do your product. Okay, but that's your basic introduction to GeoGebra. The best thing to do is to play around with it a little bit, then start over and do your activity that you're trying to do. GeoGebra is a very powerful tool. I love it for teaching Euclidean geometry. So if you end up doing this in high school, I would strongly recommend that you use it at some point.